So we're going to be working on the graphing lab today, guys. Okay, so if you go into Google Classroom, okay, you will find it posted. You just click on it, and there will be a couple of files in here, right? One of them is graphing lab data. You're not going to need that because you're here, and you're going to get your own data. This would only be if you weren't here, or if for some reason your data doesn't work out, you could use this file, but you guys won't need it. Okay, there is also this graphing experimental data file that's a PDF. That's just the lab sheet. Okay, it's what I'll be working off of when I'm going through it with you. Okay, and then there is your lab report file right here. So it'll say your name instead of mine, and it'll say U1 graphing experimental data lab report. That's the one you need to have open right now, because you're going to want to type a few things in there as I walk through the pre-lab activities, the expectations for the lab report, etc. Okay, you'll want to make some notes in there, okay, so that you can get obviously as many marks as possible on the lab report itself. Okay, so that's the one you need to have open. Okay, if you click on it, it'll open it in Google Docs. It's essentially a template that's already built for you. All you have to do is fill it in. All right, questions on that part of it? Okay. So as I said, I'm going to be working off the PDF document. So that's that other file that's in there. This is it right here. Okay. So the problem we're investigating today, okay, is that we want to figure out the speed of a toy cart, okay, as it travels along. The only things that we're going to measure are the position of the cart and the elapsed time. Those are the only two things that we'll be measuring in order to help us determine the speed of these carts, right? So really, what we're looking at here is what's the relationship between position and time for these carts that travel at a constant velocity. Okay, that's really the problem that we're kind of investigating here. Now, for our variables, okay, the expectation for the design part of this lab report is as follows. You will identify the manipulated, responding, and controlled variables, and you will explain each one. All right, so when we're identifying our manipulated variable here, okay, the experiment's going to run like this. We're going to have the cart traveling away from us while we measure its position as time elapses. All right, so for this experiment, and I'm giving you an answer here, so be ready. For this experiment, the manipulated variable is time, because time is going to determine what happens with everything else. We are deciding how long the experiment will run for. Okay? So in that way, we are manipulating the time for the experiment. Okay? If we allow the cart to only travel for 1 second, it won't travel as far as if it travels for 5 seconds. Okay? In that way, we're manipulating the time, the length of the experiment, which affects everything else. Okay? Your responding variable is usually one of the things you're measuring. You're usually measuring your manipulated variable, and you're usually measuring your responding variable. So the other thing we were measuring was, started with P. Position, right? Okay, we'll get distance from that, but we're actually measuring the position of the cart, okay, at various points in time, right? You have to have an explanation as to why the position is responding in this experiment. Okay, it has something to do with the explanation I gave you for time. The longer we allow this thing to go for, blah, blah, blah. Okay, so you need to have an explanation for that variable as well. For your controlled variables, you need to identify 3 controlled variables. That is, things that must remain the same throughout the experiment in order to not affect it. Okay, or to affect the results you get for position and time. One of the things we need to control in this experiment in order to make it work, since we're doing this on a position time graph, is actually the velocity of the carts. Okay, they need to travel at a constant velocity. If they accelerate, our graphs are just not going to look right, and we're not going to be able to do what we need to do here. Okay? This whole experiment surrounds an object traveling at a constant velocity. Therefore, the velocity must remain constant or be controlled. All right, guys, following the level of detail I'm looking for in my explanations here? Okay, you got 2 more controlled variables you have to come up with. Okay, I've given you about 3 or 4 free marks here already. So, okay. Okay, 4-hour hypothesis. The hypothesis is arguably the most important part, okay, of an experiment. What 3 words should a hypothesis contain? If, and, then. Okay, those are the 3 words that a hypothesis should contain, because a hypothesis is hypothetical deductive thinking. It is a statement that says, if this is true and this kind of experiment is run or this kind of test is performed, then the results will be as follows. Okay, you're saying, I think this is what's going on. I'm going to do this to test it. These will be my results if I'm right. Okay, is effectively what a hypothesis needs to say. However, it always needs to say that without I, us, or we in it. Okay, a hypothesis needs to be repeatable by other people. Okay, so for if I was doing, let's say, an experiment on the effect of listening to music while studying, okay, I would have a hypothesis that might go something like this. If different types of music affect the brain differently, and 5 students are allowed to listen to different kinds of music while studying for an exam, then it will be found that the students listening to the least chaotic music will perform best on an exam. Okay, I never mention myself in that hypothesis. I never mention anyone other than the subjects of the experiment. Okay, but I say, here's what I think the relationship is. Okay, here's what I'm going to do to test it. And these are the results I'm predicting. Okay? That way, in my conclusion, I can say, I predicted these results and it didn't happen. Therefore, my hypothesis is rejected. Or, these are the results I predicted. That's pretty much the way it went, so my hypothesis is acceptable because upon analysis, the data seems to support it. Okay, something along those lines. You have to put yourself out there in your hypothesis. You have to be willing to accept that you could be right or wrong. Okay, a hypothesis in science is not like politics. You can't sit on the fence and say a bunch of stuff that actually adds up to nothing. Okay, you have to take a stand and you have to say, this is what's going to happen. If you're wrong, so be it. Most hypotheses in science are wrong. That's how science works. Okay, you have to be wrong a bunch of times before you're right usually. Okay, very few times is somebody actually right the very first time. Okay, so in an experiment like this one, okay, the if part of our hypothesis, okay, should probably talk about, let's say, what the relationship between position and time would be for this experiment. That would be, is it linear? Is it exponential? Is it inverse? Okay, like what kind of a graphical relationship am I going to see here? Okay, so the if part should talk about the relationship between position and time. Okay. The and part of our experiment is a brief description, or sorry, the and part of our hypothesis is a brief description of the experiment. Brief, okay? You don't need to go into detail, okay? Basically, in this experiment, constant velocity carts will be run along the floor while their position and time are measured, okay? Something along those lines in your own words, okay? We're just describing the experiment briefly. Okay? In the then part of this hypothesis, because you've said in the if part what kind of relationship you think there is, in the then part you should tell me how you're going to calculate velocity from your position time graph. Something we talked about yesterday. Okay? You can get velocity off a position versus time graph in a certain way that we talked about yesterday. Okay? Okay, so a hypothesis is probably going to be, a couple of lines. Okay, it's a long sentence, but it's a couple of lines usually. All right, so the experiment itself is going to work like this. We're going to have these little motorized carts. These are pretty much brand new. We got them in June. Okay, I think most of them have only been used once or not at all. So they actually run properly. And they all have this incredibly fancy high-tech spoiler on them. okay? Because they go so fast that if we don't have this to create downforce on the back end, they'll just fly away. Actually, no. Okay, the cardboard spoiler is there to help our sensor see the cart. Okay, it's a bigger target. The waves, the sound waves it emits reflect off of this better than they do off just the cart, and we get better data. Okay, it doesn't tend to miss the cart as often as when the cart's not towing along that fancy spoiler. Okay, so that's the purpose of the cardboard. Okay, it'll be on every single cart. Okay, so every single cart will be treated similarly. Might be something in the design. Okay. And then we'll have this electronic measuring device. All right, so what you have here is a two-part system. This part here is the Bluetooth transmitter that you'll have to pair to your phone. I assume you all know how to pair a Bluetooth device to your phone. Okay, and then this is the measuring device. It's a motion sensor, okay? And when it's on, it emits kind of a very light ticking sound, okay? And that is just a Doppler thing, okay? The sound waves go out, they bounce off the target, they come back. The time it takes them to come back helps it to determine how far away it is, how fast it's moving, all of that, okay? These things will actually measure a bunch of stuff we're not going to need for this experiment, okay? They will, like I say, measure the acceleration of the cart, which will effectively be 0 most of the time or very close to it. They'll measure the velocity of the cart, which is another thing we're not going to need, okay? We just need the position and time data for this, and they should be sampling at 10 hertz. That is, they will take 10 measurements every second. Right? Way better than the way you did it in Science 10, where every 5 seconds you put a little piece of paper down on the measuring tape. Okay? This will be way more accurate than that. All right, so here's how this is going to work. Okay, how many of you put this? Oh, I didn't ask you guys to do this yesterday. Okay, here's what we got to do. Here. All right. Regardless of how you got the data, whether it was emailed to you or shared with you through Google Drive, you're going to see a file that looks like this. It says exported data.csv. Okay, that's comma separated values. We're going to use that in a spreadsheet here in just a minute. Okay, so if I click on that, okay, or double click on that, it gives me this. This is a mess. I don't want to look at it like this. Okay, so what I want to do is open it with Google Sheets, which will be an option near the top of the screen on your Chromebook. Okay, so click on that and allow it to open it with Google Sheets. Okay, it'll take a minute to convert it. And then you'll see this. Obviously, I don't need all of this data. So there's some columns I want to delete right off the bat. Okay, the first thing is I want to delete this run date and time data. Okay, so I'm just going to delete that column completely. Okay, but I'm going to keep the time because time is one of my variables and I want to have that there. Okay, for run 1, this is the position data right here beside it. That's also something I want to keep. So I'm going to keep all of that. Okay, and then I'm going to delete the velocity and acceleration data for run 1. So I'm just going to click on the little triangle there, delete that column, delete the acceleration data. Okay, I'm also going to delete the date and time information for run 2. I don't need that, so I'm going to delete that column as well. Okay, now I've got another column of time. The times are the same, so I don't need to keep them both. All right, obviously it goes a lot further down for my for this run, so I'm just going to keep whichever one's the longest. So this one I'll delete. Okay, so I'm deleting run 2's time. I'm going to keep run 2's position data, and I'm going to delete the other 2 columns. Okay, so all I should have left is one time column, and that needs to be column A, and then my 2 position columns. Now, the next thing I want to do is I want to get rid of this first row because when I try and graph it, if I have that first row, it's going to be messy. So all I do is I just modify this, okay? I just write position run 1 here, okay? And then I do the same thing down here at this for position run 2. I just write run 2 beside it. And then I'm going to delete the first row. Okay? That's the data I need to have. Okay, so position data for run 1, position data for run 2, and the time. The time needs to be the first column. All right, so if you got to move things around, move them around, but time needs to be the first column. At this point, I want to build my graph. So I'm going to highlight all of my data. All right, so I'm just going to click in the first box here where it says time in seconds, and I'm going to highlight everything. Okay, like so. Is there going to be data in there that's not going to fit? Yes, there's probably going to be some points in here that I'll have to delete, but it's easier to do that once I see it on a graph. I can always go back and delete them then, and then I can watch the graph change as I delete the data that's essentially incorrect, okay, that was misread. All right, so now that I've got that all highlighted, I'm going to go to Tools. Sorry, I'm going to go to Insert. Sorry, not Tools. Insert. Okay, and I'm going to go to Insert, and I'm going to go down here to where it says Chart. All right, I click Chart, and it's going to bring this up. Google Sheets never picks the right kind of graph, ever. All right, so what you have to do here is first off go to Chart Type here where it says Stacked Column. You don't want that. You want to scroll down till it says Scatter. Okay, we want a scatter plot of our data. So click on Scatter, and you'll see this. Exactly what we want. We now have a position versus time graph set up exactly the way we want. Okay, at this point, we got to do a few things in terms of making our graph look the right way, giving it a proper title, making sure the axes are both labeled. The x-axis is fine, it says time in seconds, but there's no label here. So I go over to Customize, and this is where I can make changes to my graph. All right, so I click on Customize, and I can go to Chart Axis and Titles. All right, I'm going to probably change the title so it makes a little more sense, like okay, something like that. And if I click up here where it says Chart Title, it gives me the options to label the different axes. So I got to change my vertical axis title because it doesn't have one right now. So I just write position in meters. It'll update that automatically. It shows up here. All right. Now, luckily for this group, they don't have any data that doesn't fit. Okay, like their data is perfect. They have no points that are out. If your group has points that are like way up here, it's easy to eliminate them. I'll show you how here in just a second. Okay, now that my graph looks effectively essentially right, what I want to do is go to Series. Okay, because I need trend lines. Okay, I need best fit lines for each car. So what I'm going to do is click on position 1. Okay, so run 1 here, and I want to put in a trend line. Okay, so it drew it in there, but my points are so big that I can't see it. So I'm going to make the points like really small. Now I can see the line. Okay, and I'm going to want the label for that. So if I scroll down here where it says label, I want it to be the equation of the line. Okay, so that's going to spit out for me y equals mx plus b for that car. Okay, so when I click on that, you can see here it is. So it's y equals, this number is m, 0.356, times x, and this number here, 0.078, is my y-intercept. It's b. Okay, so Google Sheets spits out the graphing equation for each line. So I'm going to do the same thing for run 2. Okay, I'm going to make the points a little smaller so that they're not obliterating the line, put a trend line in there, and add my label. All right, and you can see here, okay, the slopes are pretty close. Okay, that kind of makes sense for the way it went. Okay, but I have the equation for each line. Okay, if you don't like it being on the top of the graph, you can change where that goes. Okay, the legend can end up on the right if you like, it can be over there, wherever you want it. Okay, so now that I've got all that done, okay, it's essentially ready. The chart editor is all done, so I can just get out of this. And now I've got my graph. Okay, if I find that some of my data is not good, like let's just say that I want to eliminate this point right here. Okay, let's say I didn't like how this point was. I'm just going to change it so that it's obviously way out. Okay, I'm going to make it like okay, so you see how it's like now way up here? Okay, obviously I don't have a point way up there. Okay, that point is obviously incorrect. So all I'm going to do is find that point on my data and just delete it. When I delete it, it automatically modifies the graph and the best fit line to reflect that you've eliminated that data point. Okay, so you'll have to do that if you have any data points that don't fit, okay, that were obviously just a mistake. Okay, the sensor detected something other than the cart, somebody walked in front, just eliminate that. Okay, you can eliminate those and go with the remaining points. That will work just fine. Okay, everybody with me there? All right, so that's your data. Okay, when I've got this all ready and built, okay, I want to bring all of this stuff over to my lab report. So I'm going to copy my chart, okay, by just going Control C, go to my lab report and put it in right here where it says to put it. I'm going to paste that in. I'm going to link it. By linking it, if you make changes after this, they will change automatically. Okay, the change will be reflected in both files, which is good. Okay, so I'm going to paste that in. All right, so there's my data, and then I'm going to bring my graph over as well. So I'm going to go in here, click on the graph. Okay, just, sorry, I'm going to make sure I don't have anything else highlighted. Okay, I'm going to copy the graph over. So copy the charts, take it over to my lab report as well. Come on. Not bringing it over. Hang on here. Okay, and I'm going to paste that in. Now my graph is over as well. Now from there, you can answer the analysis questions, okay, or analysis questions. So let's quickly talk about the analysis questions here. Okay, so we've already done this part where we used Google Sheets, we plotted the position time graph, okay, we got y equals mx plus b. We want to use that equation to determine the velocity of both cars. Here's what I want to see for that. Okay, I want to see the equation for each car. Okay, so that's like, for example, right here, this is y equals 0.356 times x plus 0.0783. I want to see that manipulated for velocity. So whatever part of this equation you think represents velocity, I want to see the equation manipulated for that. Okay, that means you'll have like, you won't necessarily have a value for y or x. You can just leave y or x in there without actually putting in a number, right? I want to see the equation manipulated for velocity for each car, okay? And then show me that velocity number with the right units for velocity beside it. That's all you have to do for the analysis, okay? Is show me, I understand this part of the equation represents velocity, here's the right units and how I got it, okay? That's what you need to show me for the analysis. There's not much to do there, okay? Then in your conclusion, okay, copy and paste your hypothesis. Okay, it says restate your hypothesis, make your life easy. Go up there, copy and paste your hypothesis, bring it back down. Okay, and then tell me, based on your graph, based on your data, is it possible to accept your hypothesis the way you wrote it? Okay, so you can say stuff like, the pattern on the graph shows this, that pattern indicates that the cart was doing the following things, that fits with what the hypothesis said, therefore the hypothesis is acceptable. You need to talk about your data and your graphs and your analysis when you're accepting. You can't just say, I was right, good for me, okay? I'm going to go, you were right, Lottie freaking daw, you didn't tell me why. Okay, if you want to get 4 marks for your conclusion, explain why your data supports your hypothesis, right? The evaluation part, okay, 2 sources of error and how you could improve them if you were to repeat the lab. Okay, 2 sources of error and how you would do the lab differently to account for them. All right, and then that's it. Okay, that's what you have to do for the lab report. Okay, questions on that? Okay. All right, so you got the rest of class to work on this. That's actually quite a bit of time, so you should get a pretty good chunk of this done, I would think, as you still have a half an hour almost to work on it.